Hey everybody, this is Mr. Storm, and today we are going to explore what it takes for you to complete your first power standard in Term 3, which is called Rat Race. Rat Race is this game that I came up with. It's a little maze game, and the concept of the game is you're going to play as this little hunk of cheese here, who's moving through this maze collecting all of its little pieces of cheese that have dropped off of his body, while avoiding these rats here, which are going to move back and forth in the maze. And if you hit the rat, then it's going to restart the level. But if you collect all of the cheeses in the level, then it's going to move you to a new scene, which, yeah, sure, I'll save, which looks like this. I'll show you in the game view, which looks like this. You win. And that's not really great looking. Let's go back to scene view. Come over here. It's going to say, you win, press escape to close, right? And so that's how the game is going to move. That's how you're going to be able to move through the game. That's the game idea. So let's open up the game scene again. Okay, now in order to complete this project, you should have everything ready to go. The only thing you need to do is write these two scripts. Now you don't need to name them when I've named them, cheese move and rat move. You can name them player controller and enemy controller if you want. That's totally fine. But you're going to need two scripts for this game because one script is going to be attached to your cheese object and the other script is going to be attached to your rat objects. Now the nice thing is these rats are a prefab. I've already created a prefab for the rat. So with the rat, all you have to do is come up here to the prefab itself and then attach the rat move script to the prefab, and it's going to attach it to all of your rats. Now when you're done writing the scripts for the game, this is what the game should look like, and this is how it should perform. So your rats are going to be bouncing back and forth in the maze. As soon as they hit the edge of the maze, they're going to flip around, and actually not really flip around, but they're just going to reverse direction and come back the other way. So they'll be constantly bouncing back and forth in the game. And then your cheese can move around just like this, and when it walks over a cheese dot, it picks it up and it adds 1 to the count of cheese. And if I run into a rat, then it restarts the game. All right, so that's essentially what we're looking for. We also want to check to see if we have collected all of the cheese dots, then we move on to the next scene. Okay, so let's talk about how to complete this. Now, I'm not going to write these scripts for you like I did with the last project, but I will show you kind of what, I'll give you a couple of tips on how to make these scripts work really well. So let's start with the cheese. So I'm going to create a new C# script, and I'm going to call it player, and we'll go over the logic behind this script, and I'll show you some of the things that you're going to need to know in order to write this script successfully. By the way, you'll notice that I'm using a newer IDE for this video, or not a newer IDE, but a different IDE for this video. This is called MonoDevelop. The reason I'm doing this is because I want to show you all the different IDEs that you could see that you might come across when you're looking at tutorial videos on Unity. A lot of people use MonoDevelop in their videos. Now, MonoDevelop is no longer supported in newer versions of Unity, but you will see this IDE, so I wanted to show you what it looks like. From now on, after this series, I'll be using VS Code, which is the IDE you should be using. Okay, so let's talk about this script a little bit. Well, we're going to need some variables up here, obviously, so we'll probably need a cheese variable that is a rigid body, 2D, right? And that's going to be for our player. We're also going to need a cheese count. We're going to need a cheese total, right? And we're going to need a public speed, right? Now, notice I'm writing all this stuff in comments because I'm not going to teach you again how to declare variables and create variables. You should already know how to do that. And just in the ease of making this faster. I'm not going to write the entire script for you either. this is going to be a test of how much you learned in the last project and in last semester. So we're going to need a couple of variables here. Now, the reason why we need the cheese count variable is because I need to be able to count how many cheeses we've picked up so far, right? And the cheese total variable is going to check how many cheeses there are total in the level. And then it's going to, at some point, we're going to compare those two. And if those two are equal, then we'll move to the next scene. All right, so in the start method, we're going to want to set the reference to the rigid body 2D, right? Just like we did in the last project, we did that with our movement script, so that's exactly what we need to do here. Then in the update method, we need to do all the stuff to make our cheese move. However we did it in the last project, just look it up there, and that's how we do it. We want to make it move. Alrighty, and then we also want to compare, let's see, cheese count with cheese total, move to the next scene if they are the same. Now we're doing that in the update method because we always want to be checking for that count. We want to make sure that as soon as we pick up that last cheese, it moves right to the next thing. So we always want to be doing that in the update, so we're always checking for that. And then in order to pick up the cheese, we're going to need some kind of, let's see, trigger collision detection, which tells me if I've picked up a cheese, add to cheese count when cheese is picked up. Right, so we're going to have an on-trigger enter 2D method down here that's going to check to see if we've collided with cheese. If we have, then we're going to add that to the cheese count. Now, whenever you're looking for collided objects, remember that we're going to look for it by name. So to figure out its name, you just come back to Unity, and I've named all of my cheese balls cheese ball. So if you just look for it by name, cheese ball, then you should be able to work. All right, and then the last thing we need for this script is we're going to need a collision method. And that collision method is going to restart the game if you collide with a rat, right? So that's all the stuff we need for this script. Now you can write the script based exactly how I wrote it, or you can come up with different ways, more efficient ways to write your script, however you want to do it, as long as it works and does the things we want it to do. Let's talk about the rat script here real quick. We'll call this enemy. All right. Now the rat script is going to be a little bit easier because in the rat script we don't have to do much. All we have to do in this rat script is get it moving in a specific direction. I'm actually going to write this rat script for you, and you can follow along, and this will be half your project that'll be basically done. So let's actually do this. First of all, I need a private rigid body 2D, which is called, I'm going to call it rat. And then I need a public float called rat speed. You can call it whatever you want. Again, I'm going to set it to 8 for now. We can change it later because it's public. And then in the start method, I'm going to set my reference to rat to be equal to get component rigid body 2D. And all right, now let's talk about what we want this to do. First of all, in my update method, I want my rat.velocity to go direction times rat speed. Oh, I haven't created the direction method yet. All right, so let's talk about this direction. Now, this is going to be different from the way we move our other characters because, first of all, we're not taking input. your rats aren't going to move based on your keyboard presses. So we want it to move on its own, right? So we don't need to take an input. But what we do need to do is create a new vector2, and we'll name it direction. And we're going to set it equal to new vector2. And in these parentheses, we'll set it to 1 and 0. Now here's what I'm doing. Here's why I'm doing it this way. Setting it to a 1 means it's going to start moving to the right on the horizontal plane as soon as we start, right? But setting it to these values, actual hard-coded values instead of vector2.right, allows me to change this number using the code. So we're going to set rat.velocity equals direction times speed, rat speed, sure. And then, so now it's going to start moving to the right as soon as the game starts, because that's how we set it up here. Direction is going to be to the right. But if we collide, so void on collision enter, we'll say 2D. Now we don't even need to pass any arguments into this, because if it collides with literally anything that is a collider, then we want it to move. Because if it collides, there are only two things with colliders in this game. There's a rat, or three things. There's rats, there's the player, and there's the maze. If it hits the player, the game's going to restart anyway, so we don't care. If it hits the maze, it's going to bounce back. And it can't hit any other rats because they're not close enough to each other to hit. So we're just going to say on collision enter 2D. And we're going to say direction dot x times equals 1. So all this is, or sorry, not 1, negative 1. All this is doing is this is saying, all right, so this direction variable, let me put in that right there. All right, so all this is saying is the direction variable up here, so direction, is going to take the x value. And remember, in a vector2, the first thing is an x, the second thing is a y. So it's going to take this x value and times it by negative 1. When we times a positive number by a negative 1, it basically makes it the negative version of that number. But the nice thing is, if we times a negative number by a negative 1, it makes it the positive value of that number. So this is a handy little math trick that we can use to swap this from a negative to a positive over and over again without having to set up a complicated, a bool structure or if-else statements to try to figure this out. This right here, this direction dot x times equals negative 1 will allow us to swap the positivity or negativity of that number basically just with one line of code. So it's a really easy way to write the script. And this is the whole rat script. So that rat script is done now. You can just literally copy what I've written here and be done. This player script, however, is going to take a little bit longer to write, and I want you to actually take some time and figure out how all of this stuff is implemented here. Now, once you're done with your scripts, I want you to upload both scripts to Canvas so that I can see them both. And again, I will attach them to my project here, and I will make sure that they actually work. And if they do, good, you have a full, you get full points on the power standard. If you make some mistakes in the player script, I will give you some feedback and tell you how to fix it, and then you can fix it and return it and get a full, full credit. Here's the thing, because this is a power standard, I want you to make sure you get full points. I want you to get full credit on this assignment because this is a huge part of your grade. So if you have any questions on this assignment, or you need clarification, or you just want me to walk you through it again, please let me know, and I'm more than happy to do that. I am always here. Just let me know, and I will come give you a hand. Until next time, thanks for paying attention, and I'll see you later.